Okay, so this video is on linked list. So in this video we'll look into two problems basically which are almost similar, which is to find the middle node of the linked list and the kth node from the end of the linked list. So these are the two subproblems that we'll be looking in this video. So we'll not delve much further into linked lists, deeper, but we'll just see what it is. Okay, so the linked list, so we have two things. Every node will have data and there will be one head node. Okay, and this head node will be pointing to the first node, and this will have data and a next pointer or a reference that will be pointing to next node. And here again this will contain data along with the next pointer. Okay, data next, and the last node will be null, will be pointing to null. So this is how you have a linked list, right? So I want to find the middle element, middle node. So say I have a very big linked list. Okay, yeah, not so very big, only 5 elements, let's consider. And this will be null, and head will be pointing to this. Okay, this will be the next pointers. So consider that there are 5 nodes. So how will you find the middle node of the linked list? So one possible way or a naive way would be like to count. I will traverse this list till I reach null, and I will have a count which is 0 for every node. Here I reach the node, I'll make it 1, I'll go to the next, make it 2, here I'll make it 3, here I'll make it 4, and here I'll make it 5. Next I reached null. So when I reach null, I will return this result, 5 nodes total, and I'll do 5 by 2, which will result in 2. So now I'll go 1 and 2 steps, so I get this. But this would again require traversing the whole linked list once and then again traversing half of the linked list. So can we do something better? Okay, so that is the question. So how can we do it? So these questions involve a small trick, that is to have a slow pointer and a fast pointer. So how do I go about this is I'll have a slow pointer uh, that so slow, okay, which I'll show it as S, and I'll have a fast pointer. For every 2 steps that fast pointer takes, I'll move 1 step slow pointer. So both, okay, I'll have slow and fast here, both pointing to the head, and I'll move fast by 2 steps. Okay, fast moves here and next here fast. Slow moves here 1 step. Fast is here and slow is here. This moved 1 step, whereas this moved 2 steps. So again, I'll move this fast 2 steps here, and slow will move by 1 step to here, this node. So again, fast I will move it 2 steps. Okay, here. Slow will move 1 step. But here fast is already at null, it can't move further. So I reach the end of the list. When this fast pointer reached the end of the list, slow pointer that was moving 1 step at a time will be at the middle node. So this is one neat trick. What if I ask you to do, if I give a very big one, see, okay, this big, and I'll ask 1/3, okay, another one node I'll add. So divide this list into 1/3 parts. So what I can do is I can have a slow, first it will be pointing to null, slow and fast. Head, not null. There will be a head that's pointing here. So this will be at head. I'll move fast 3 steps. I want to divide this entire list into 1/3, right? So fast will move 2 times, 3 times. And this slow will move once, something like that. So that will divide the list into one third. I mean, you get one third of it, and by that time you can have the count how many steps I took for the slow pointer, and again take that many count steps from here. So another one third, something like that you can do. Okay, and this is dividing into half or one third or something like that. So next is finding the kth node from the end, right? So this is another question that is commonly asked. So let me consider one. Okay, so I have null here. So this pick the linked list. So I want to find the second node from end or something, k nodes. So what I would have do is I will have a slow pointer and a fast pointer, okay, and two pointers. So k steps I will move the fast pointer ahead. So let's consider k is 2. So 1, 2. So here I will have fast pointer and here will be my slow pointer. So now I'll go on moving one step at a time. Fast moves here, slow moves here, again fast moves here, slow moves here, again fast moves here, slow moves here, fast moves here, slow moves here, and now fast goes to null and slow will be here. Right, so I got the kth node from the back where slow is pointing to. So this is how you find the kth node from the end. Like you will have a slow pointer and fast pointer that is separated by k distance.